engines, and we've talked about how recommendation engines basically look for products that are relevant to a user. These products could be found by using different techniques: content-based filtering, collaborative filtering, or association rules. In this lecture, let's talk about content-based filtering in some detail. Given a user, content-based filtering helps us find products that are similar to the products that the user already has indicated that he or she likes. The similarity of products is defined by the content of the products being the same. When we say content, for example, if the contents of 2 books or 2 movies are similar, or it could even be attributes or descriptive characteristics. For example, the color of a pair of shoes or the brand of cameras or cell phones that you like. Content-based filtering was developed and even today is mostly used to find text documents which are similar to each other. For example, books or articles which have similar kind of content. We'll see why that is so and why text documents are the most popular use of content-based filtering. In a short while, you'll understand as we go along and describe how it works. First, you start by identifying factors which describe and differentiate products and which might be influential in deciding whether a user likes a product or not. Then you would express each product in terms of these descriptors. Examples of such attributes for books, for example, might be the genre, science fiction or comedy or drama, the words that are used in the book, and the style of writing, for example, that might be something to differentiate how 2 different books are. The author is an example of a proxy attribute that might explain the style of writing of a book. This is the crucial part of content-based filtering, identifying these factors and then mapping all the products to these factors. So you have to take every product and represent it as a tuple of numbers, a vector, which represents their possession or strength against each of these factors. So let's say you have is comedy as one of the features or factors that a product is described with. Then you could have is comedy as 1 or 0 to say whether a book is a comedy book or not. Or you could have a real number, something between 0 to 1 or minus 1 to 1 to indicate whether a book is a serious book or a comedy book and the extent of that quality of that book. So once you expressed all the products as vectors or tuples of these numbers that represent the descriptive qualities of those products, you will start with the users. You will look at the user's history, and based on that, you would create a user profile for that user. And the user profile would be having the same number of elements as the factors that you've used to describe the products. In the user profile, the number would represent how strongly the user shows or doesn't show a preference for that particular factor. Let's say once again, the factor is comedy. If the user really likes comedy movies or comedy books and has been seen to rate them highly in the past, then you could make this user profile show that the number against is comedy for that particular user would be a strongly positive number. On the other hand, if he dislikes comedy, you could use a strongly negative number to show that as well. So in content-based filtering, the first step is to take all your products and all your users and map them to these factors that you've identified. Factors that you believe are influential in deciding whether a user likes a particular product or not. Once you've done that, you could find recommendations for that user by finding products which are close to the user's profile. So that's the basic idea of content-based filtering. Let's take an example now and see exactly how this works. Let's say you are finding recommendations for movies. given a user, you would like to find movies that this user might like. The first step is to identify factors which might influence whether a user likes a movie or not. So in this case, we've identified two factors. These are two factors that we believe would be influential in deciding whether somebody likes a movie or not. These factors are where the film lies on a scale from comedic to dramatic, and where the film lies on a scale from being very commercial to being arty or independent. Now you've got to take every movie in the catalog and map them against these two factors. That is, you will find a number to represent how comedic or dramatic that movie is, find another number to represent how commercial or arty that movie is, and represent each movie on this scale. So here we've done that. As you can see, we have The Hangover, which is a highly commercial, really big box office hit, which is a comedy. Then we have The Godfather and Gunda, again commercial and very dramatic movies. The Memento, which is a dramatic but more of an indie film or an arty film. And The Sleeper, a Woody Allen film, which is a comedy, which is again very different from The Hangover in that it is kind of quirky and a little more independent or arty. Once you have represented all the movies in the catalog as product factor vectors like this, you would start with the users. So let's say we have a user, Janani, and we have looked at her history. Janani clicked on 10 movies on our website. 7 of them were commercial movies and 9 of them were dramatic movies. So we have come up with a score for Janani on each of these two factors again. Using Janani's history, we've put her on the scale of -1 to 1 for comedic strength of the movie. If it is +1, it's a very highly comedic movie. If it's -1, it's a highly dramatic movie. Since Janani likes drama, so we have put -0.9 as the score for the feature which tells us whether the movie is comedic or dramatic. We've also come up with a number on the scale of +1 to -1 to represent Janani's affinity for commercial movies versus arty movies, and that number is 0.7. So we plot Janani on this same graph. We see that Janani seems to be very close to Gunda and The Godfather. Her preferences put her very close to these two products, which also have the similar qualities. They are very dramatic and commercial. So we can show her these two movies as recommendations for movies that she might like. This is exactly how content-based filtering usually works. Identify factors which help you decide whether you like a product or not. Map all the products onto those factors, map all the users onto those factors, and then find the nearest or most similar products to a user's profile. Now, identifying these factors and creating these profiles, both the product and user profiles, this is the key challenge in content-based filtering. What attributes should we use? And how are these attributes actually generated? What should the values be for those attributes? Let's say you have this scale which decides whether a movie is on the comedic side or the dramatic side. How do you put one movie higher than the other on that scale? There might be a lot of factors which are very objective. Let's say, for example, the year of release of a movie, how much money did they make at the box office, and so on. But there are a lot of factors which are subjective as well, for which the values would be difficult to determine unless you are some kind of expert or critic. And even then you might miss something. In general though, it is very difficult to automatically generate these factors. These factors or attributes that you use are typically collected through manual data collection. There will be some sort of expert who will sit down and Map every product in the catalog to a set of important features or attributes. With text documents, you have an alternative. You could use NLP to generate the descriptors. For text documents, the descriptors could simply be the presence or absence or the frequency of terms or words which occur in the document. For example, you could take every document or article and represent them with the frequencies of each of the words that appear in those documents. Then you could find the nearest neighbors for those particular documents, and those could be your recommendations. However, recommendations are needed in other contexts other than text documents. You would need them, for example, for movies or songs or different kinds of electronic products. In those cases, you would have to have a manual data collection phase where every product and every user is mapped against the factors that you identify. This is why recommendation engines that use pure content-based filtering are less common. There is one example though of a very successful implementation of a content-based filtering recommendation, and this is famously known as the Music Genome Project. It's owned by a company called Pandora Radio, and it was a massive project that was undertaken by Pandora to build a database of descriptors for every song that they had in their catalog. Every song in the Pandora catalog is represented by a vector of 450 genes or factors which they call genes, hence the name Music Genome Project. So each song is heard by a trained analyst, and then they would score the song on these genes for what their score would be on these genes. The process normally takes about 20 to 30 minutes per song for a trained musical analyst. So you can see how massive an undertaking this project was. In the end, once you have this database, whenever a user signs up on Pandora or once in a while, the user is asked to describe their preferences, what kind of songs they like or what kind of genres they like, and then using the songs that they picked, songs which are similar are found from the entire music catalog. Then a self-playing radio keeps playing the songs which match the user's preferences. This is the concept of Pandora Radio, and it is one of the few but successful examples of an implementation of content-based filtering. However, mostly people use collaborative filtering, which doesn't require you to even know what the product is, what the description of the product is, before you can give a recommendation. We'll see how that works in the next class.